This is something we also saw in our preview during class, this idea of displaying and summarizing two categorical variables. If we're able to summarize two categorical variables at once, we can start looking to see if it appears that there's a relationship between them or not. This is going to be subjective at the moment, but as we move forward in the course, we'll get chi-squared tests and methods that will allow us to assess a little more quantitatively exactly whether or not there is a relationship. But this example we saw already with the race versus plea deal graph, right? We saw a little split bar chart kind of comparing those two races and the plea deals they were offered. So one way to do this, to summarize these, is to make a contingency table. So a contingency table puts one variable along the rows and then the other variable along the columns. So if we're looking at majors in our class, well, we usually have a lot of business. I know in the hybrid class especially, we have a lot of people who are planning to become RNs. We have a lot of nursing, and we could keep going. All right, I just paused the video to look up everyone's majors, which I realized I didn't ask on the survey, so I had to go through everyone's discussion boards on their intros and hope that they had mentioned their major and then problematically assign them a gender. So I'm apologizing now that that is a terrible thing that I've done. But I want to fill out this table so you guys can see what a contingency table looks like. So as I was going through your guys' responses, so the other really popular categories for majors besides business and nursing, surprisingly, art/graphic design. I had started throwing these people into another category, and then by the third person, I pulled them all out. And then we also had a lot of STEM, and we had some, we'll go with social sciences. And what was the last one I had here? Very distracting. Nutrition, strangely enough. Some new ones I don't normally get, especially the art and graphics design people. You guys should all be in 118, which is like a class where you do a ceramics project. But that's fine. You'll still love stats, and you can use this in real life. And then, of course, we'll have another category. So as I was counting these up, for business, it appeared that we had 3 men in the class and 3 women in the class who identified as business majors in their intro posts. In terms of nursing, I did go ahead and lump anybody who was going into like radiology tech, that type of stuff, into the healthcare field in with the nursing. So this is slightly liberal in my nursing. So allied health went into nursing as well. We had 4 men, 5 women, for 9 total allied health majors. And we had people who were STEM, who were going into for trying to do pre-med and stuff. Those people went into the STEM category, so there were a lot there too. I'll just fill that out. We had 3 men, 0 women majoring in STEM degrees. And then for the arts, we had 1 man, 4 women. Social sciences, I had to add these up because I didn't have these ready. So social sciences, I included psychology, sociology, and then political science. And for those, we had no men, but we had 4 women. Nutrition, no men, but we had 3 women. And I kept getting my little columns screwed up anyways, so I was literally just making tally marks. So I'm sorry if these are in the wrong column. You should see my thing. It's covered in scratched out marks. And then for other, let's see, we had some child development. I'm going to go ahead and make tally marks as I bring these all down. We had criminal justice. I had 3 people I threw in other to begin with, and 2 over here. Hospitality, tourism management, and public health. So we had 3 men, 6 women fall into this category for 9 total in this other area. So as you can see, the contingency table is kind of nice because it gives us a total column, which allows us to see just that single variable. If I ignore the middle, I can see that the most popular majors, not including other, or nursing and business as usual. But now we also have a lot in art and graphic design, which is totally out of the blue and unusual for me in this class. And then if I go down the columns, I can also add up, I'll make it smaller so we can fit, all of the men and all of the women so we can see what our class breakdown looks like. Now, this is not particularly accurate because, again, these are just people who told me what their major was in their discussion board post, and it's all the people who actually did that first discussion board post. So there are people who still have not done that, considering we have like 52 students in this class, and we'll figure out exactly how many people filled this out. So it looks like we have 14 men, women. Ooh, there's so many of you. This is going to be a pain in the ass. All right, I'm using a calculator. My brain can't handle. These numbers are not grouping the way I want them to. There's nothing more riveting than watching a YouTube video where someone is just typing on a calculator and you can't even see it. So if we add these together, this is a pathetic sample size, 39 of our 52 students who actually posted that discussion board and mentioned their major in that discussion board post. So some people did post but didn't tell me what their major was specifically, which is fine. So one question or thing I like to mention is that looking at this, you should get an idea of whether or not there's a relationship between these two variables. We can make some conclusion about what our breakdown in our class is, that the class is predominantly female, or that there's a lot of business and nursing majors. But we can also start saying, does it look like there's any sort of relationship between these two variables? I mean, this one's hard because we have a small sample size, but you might point to things like STEM and social sciences where we have predominantly one gender, even nutrition, right? These 3 in a row, we have only one gender showing up. Granted, they're pretty small sample sizes, but I would love to talk to those people in those nutrition classes, in your major classes. What does the gender breakdown look like in them? Same thing with those STEM majors. When you get into the higher level STEM classes, are you seeing similar amounts of men and women in your classes or not? Because there tends to be a relationship between the gender and the major chosen. So anyways, I just wanted to show this to you as one way to look at our data using a contingency table. Those contingency tables, there are multiple types of them. The one we just made had the actual counts, but we could have turned this into a joint proportion or relative frequency table. And that just means that we could have gone ahead and said, oh, if we have 39 people in our class, oops, that's not right. That this is about 8%, I'm really rounding here, 8% of our class are businessmen, right? Aspiring businessmen. And 8% of our class is aspiring business women. So we could use that to be able to sort of see the numbers a little bit more clearly, right? How they all fall in terms of the entire class distribution. Another thing you might want to do is what we call a conditional contingency table. So when we're talking about conditional, I'll come back to here. Another way to look at this, especially because look how lopsided our men versus women are in this class. We might want to say, of the men, what proportion of them are majoring in business? So 14 men, only 3 of them are majoring in business. This is 21% of our men are majoring in business. And if we look at the same value for the women, well, there's 25 women. So this is only 12% of the women are majoring in business. And so now 3 looked pretty similar, but when we look at the percents, 21% versus 12%, that's not looking as similar, right? And if we break these down, like 4 out of the 25 for our social science majors, this is 16% of women versus no percent of men, right? So we could break this all down and eventually figure out all the 100% of women and 100% of men, how they break down in terms of their majors. So conditional contingency table is really useful to look at relationships.